my daughter's 5th grade teacher when she was in 5th grade. She used it to like replace teaching, her teaching. So she was like, here, watch this Nearpod. Here, do this. Like, I was like, well, couldn't you just teach them the science lesson yourself instead of telling 5th graders to watch a Nearpod? I don't feel like it replaced the teaching, but I don't know. I mean, maybe if there are some cool pictures on it, but lucky for you, I am not replaceable. Oh, I don't want to show that one. No Nearpods for my lessons. All right, so number 13 tells you that the area of a trapezoid is 1/2. And then the actual geometrical definition is base 1 plus base 2. Here, instead of saying base 1 plus base 2, I just say a plus b, which is exactly the same thing. You have 2 different bases. Remember, a trapezoid has a top and bottom part. They're different lengths. And then that's all multiplied by the height, because we need to know how high the trapezoid is. No, you'll never be asked to memorize any of those geometrical formulas, but we may use them. So we would use them, but you'll be given the formula. So the goal is to solve for b. And what's one thing, Drew, you could do to solve b?
Well, you can get rid of the 1/2.
Yeah, let's get rid of that. Yeah, take that to the other side, so you don't have that 1/2 to worry about. So multiply by 2. Now we have 2a. Drew, what else could you do?
You could distribute the h.
Yeah, so you could distribute the h. The other d that you could do with the h would be to
But
divide it. And it's totally up to you. So do you want to distribute it through, or do you want to divide it out? Either way, you're going to get the same answer. So let's see if we distribute it through. And it kind of depends on what you notice in the problem, what you see first. And then, Drew, you would. Trying to solve for b. Right, here's b.
you can subtract the a.
So we have 2a minus ah. And then finally, there's that h right there, so we need to divide it out to get it to the other side. Got the creepy handwriting again today. So that's one way to get your answer. And that is found by distributing the h through instead of dividing it out. Now I know some of you divided it out, and that's fine as well. So if I go back to this step right here and I divide the h out first, I'm just going to show you kind of how that could be slightly different. You get 2a divided by h. I would get a plus b. And then if I took the a to the other side, I end up with 2a divided by h minus a equals b. I think some of you had that answer. The only problem with this answer is it's considered unsimplified, because if you have 2 terms with different denominators, in math we consider that an unsimplified expression. So we combine those together by getting a common denominator, and if this has an h, this one also needs the h. That's how you arrive at that equation if you did it the other way. So don't stop with 2 separate fractions. If you have a fraction and something else, combine them together with a common denominator. But Drew's way actually I think works easier by distributing the h through, so then you don't have to worry about that. Any questions? So we are going to use the calculator today. Just a little quick before you flip into the other packet. The next worksheet in your packet, in that homework part, would be the solving equations. If you have the first 2 done, or inequalities, if you have the first 2 done, awesome. If not, you have to do those first 2 and then the rest of it for tonight's homework. But if you got a chance to start it last night, perfect. A lot of it is graphing. So like the front page is algebraic solving. The back page, when you flip it over, is a lot of graphing with the calculator. If you're asked to graph with the calculator, please make sure you show a little sketch. Questions with that? So in your notes packet, I believe we're turning to page 18. So you can get out your calculator. If I don't have one with me, so I try to remember to bring one, but I don't have one with me today. Does everybody have one? I'm going to show you how we can use inequalities in the calculator. Something that we didn't really get to do last year, but there are definitely functions of the calculator that we'll use that you've never used before, which is how, it should be. We're learning new math concepts, so we should be able to see how other things in that calculator work. At the top of page 18 is example 1, and we have this inequality 1 minus 3x over 2 is greater than or equal to x minus 4. This was the first problem that we solved yesterday as like the warm-up when we started the inequality. So if you flip the page and look at number 1, warm-up, there's this question here. We did it algebraically. So I want to show you how the graph looks in the calculator so that you can kind of see what you're looking at if you do want to check your work. So how would you place this into the calculator? That's the first question. How do you think you put that in the calculator? Oh, wow. Drew, what do you think?
Solve for x.
So we could solve for x, but we're actually not going to. We're not going to do any work to put it in the calculator. Which is like, no work to get it in the calculator. We're going to look at this as two equations. I know there's an inequality sign, but here's my inequality sign. Whatever's to the left of it is going to be equation 1. So in y1, we're going to place 1 minus 3x over 2. Whatever's to the right is, we're just going to make equation number 2, which is x minus 4. So in your calculator, we're going to put those two equations. They're both linear, so we should have 2 lines. You can graph it just to see that you got 2 lines there. 1, 2. There's my 2 lines. But I want you to actually see the inequality part in the calculator. So if you go back to y equals, the question in the packet says we want to show when y1 is greater than or equal to y2. So here's my y1. I need to switch this so that it says greater than or equal to. And that actually can change. So if you arrow over left past y2, you now get that little line to blink. And if you hit enter, that little line changes to a darker line. Hitting enter again changes to a line that has shading above. If something is greater than or equal to, we shade above the line. If it's less than or equal to, we shade below the line. So I want my graph to shade above this line because my y1 is supposed to be greater than or equal to y2. And then when you hit graph, if you have one of those fancy backlight calculators that have all the colors, your graph looks a little prettier than mine. But we all should have this shaded section as the solution. So now you can shade inequalities with your calculator. So my answer is this piece here. Whatever's in the shaded area is the answer. But we still need to figure out what that means. So the one thing that you have to do is to first figure out where these meet. Because that's the place where it goes from above to below. Answer versus not the answer. How can you use the calculator to find where they meet or where they intersect? What function do we do there? Ashley. Yeah, intersection. So hit second trace. Intersect is number 5. You hit enter, enter, enter. Pretty much it's just jumping from one line to the next. And I see that the intersection point is at 2, -2. Now when you solve, you're solving the equation for x. So we're only worried about the x being -2. Or how about +2, not -2. So we're going to write an inequality that shows that my graph for the x values, now this is where it's tricky because you're like, yeah, but it's above, but for the x values, it is shaded in this area from everything for the x from negative infinity, and then it stops at the x value of 2. So the solution for x, so you're thinking x, goes from negative infinity and it stops at the x value of 2. So I would say negative infinity, comma 2 with a bracket. That describes the horizontal distance where my line is greater than the other one, or where my line is in the shaded region. The trickiest part is to think that you're really looking at the x values left and right, because we're still solving for x. Even though you're thinking above and below, we're describing the x values where that works. Questions? So we're going to do this again for the next inequality so that we can kind of get an idea of what's going on. Make sure you write yourself something down there so that you know what you were looking at. So maybe draw yourself a little graph. Doesn't have to be super fancy, but the one, here's one line, or here's my other line. So this is the little piece that we were looking at, and that piece is when x goes from negative infinity to 2. So I'm looking at the piece that's above the other line. So this piece is above my line x minus 4, and that exists from negative infinity to 2. Sometimes the algebra is actually easier to think about than looking at the graph. So if you look at the one underneath, there's a little part that I omitted when I was typing this. So it says, use the graphing calculator to approximate the x values, values of x, that satisfy, our equation is negative x plus 8, when negative 1 is less than y, which is less than negative 3. So we're going to try and work through this the same way, except now I have 3 things that we need to plug in. The one on the left says y is greater than negative 1. So y1, we're going to try and make greater than negative 1. And then the middle one is going to be my equation, because that's squished in the middle. I'm going to make that y2. And then y3 is the one on the right, and that's supposed to be less than 3. So pretty much working left to right. So the left number is negative 1. The y in the middle represents the equation that we're working with, because that equation is supposed to be in between these two numbers. And then the one on the right is the 3. So we're going to see if we can try and get the calculator again to shade. So if we look at these in the calculator, I'm not going to worry about doing any of the shading at first. I just want you to kind of see what the graph looks like. So we have a negative 1. Was it x minus 8? Negative x minus 8, thank you. Plus 8. Oh, I have my signs. Negative x plus 8. And then the next one was 3. So before you do any of the shading, just hit graph, because you might not even need to shade. Maybe you don't need to shade for this one. So y1 down below, y3 up above. Our goal is to figure out when is y, or my graph, my equation, in between negative 1 and 3. That's what we're really finding. So when is the equation in between these two numbers? Well, if you look at the picture, where would the equation be in between negative 1 and 3? Where would that be? Ashley? Somewhere on there, right, Drew?
0, 1, 2. Like in the middle.
Yeah, right here in the middle. I mean, my equation is squished in between two y values, so I'm looking at the piece of the line that's in the middle. So this is the piece of the line that we're looking for. So we need to find this number and this number, which you might be able to actually count because they're whole numbers, or you can do second trace. But the solution is in between -1 and 3, and I'm trying to figure out what that solution is. But we need to know the x, because you're describing where it starts for the x and where it ends for the x. So Julian, do you know what the starting x value is right here?
Is that 5?
Yeah, it is 5. And then the other x value, 9. So Julian, it says -1 is less than y, which is less than 3. How would you write that as interval notation?
Wait, what are the numbers?
You told me x was 5 and x was 9. The inequality symbols are less than.
So the x is greater than 5 but less than 9. So do we do a bracket and then 5, comma 9, and then another bracket?
You're so close.
Parentheses.
So from 5 to 9, my line is in between those other two y values. And again, you're describing x, which is really hard because we're still solving for x. So if I solve the equation, I should get those same two values because I would subtract 9 and I should end up with those same two numbers. Or subtract 8, I'm sorry. And I should still end up with those same two numbers. Questions? So if you don't want to do the shading part, you can kind of visually look. This one, I think the shading works better if you have the color-coded calculators. But just to show you the shading, so you never do anything with the first equation. You would change the second one because it was greater than or equal to, so here's my, or y is greater than, not equal to, greater than -1, so I would change this to be greater than. There we go. And then y has to be less than 3, so I would change that to less than. So greater than, shade above, less than, shade below. Mine doesn't look as nice because there's a lot of shading going on. So where the two boundary areas are darker, we're looking for the numbers in between where they kind of overlap. So I have the horizontal lines and the vertical lines as an area in between there. Questions? The other two problems that we're going to look at, we're going to do algebraically. So everybody thinks the calculator is sometimes easier, but I think algebra is always a good way to go. So try and solve example 3 algebraically. And then after you solve it, make sure you're writing your answer in interval notation. If you need to draw yourself like what the number line would look like to help you with the interval notation, you can. So we solved absolute value equations, now we're looking at absolute value inequalities. Scott, what would you do first?
Move the 3 over.
Yeah, move the 3 over. Oh, that is a 4. And then, Scott, what would you do? So first one always stays the same. What's the second one look like then? Yeah. So you could, he made the left side negative. The other option would be to say x plus 4 is less than or equal to -14. You get the same exact answer. So whether you're making the 14 positive or negative, or you're making the stuff inside all negative. So you're going to get the same answer. Make sure you flip the sign though. This is just the less than. So the sign needs flipped because once you multiply by a negative, we need to change the sign. So one answer should say x is greater than 10. The other answer should say x is less than -18. So which whichever way you solve those equations, those should be your two inequalities. Our goal is to write that as two inequalities with interval notation. And if you need to kind of look at what the graph is saying, just make yourself a quick little graph. So we have a negative 18 and a positive 10. It says less than negative 18, greater than 10. So that's my picture. Yesterday we talked about what the inequality would look like, what the picture looks like, what the notation looks like. So that's my picture. What would the notation then, interval notation, Asher, what would that look like for our two solutions?
It would be negative infinity, or parentheses, negative infinity, comma, negative 18, parentheses, and then u, parentheses, 10, comma, 8.
Why do you put a little u there?
It's both.
Because it's both. So that little u means in union with, or in conjunction with, or both of them together. So we need that little u to show that both are the answers, not one or the other. Any questions? My math classes in college, we used a lot of like notation for different things. This little 3 dot guy, that means the word therefore. So I would do a whole bunch of proofs and we'd have these symbols kind of inserted in the proof. Question?
So whenever, like if you did x plus 4 is greater than negative 14 instead,
Mhm.
don't you not have to put sign because
But you're still putting a negative in. Whoop. So anytime you place a negative on one side of the equation, you're still multiplying in theory by a negative number. Because you took a positive value, you had to, in order to get a negative, you have to multiply by the negative. So the sign does have to flip. Other questions? So I think there's one final problem down there. Again, first solve algebraically, and then we'll see if we can look at what that means graphically. So that you can kind of see how the two go together. The algebra supports the graph, or the graph supports the algebra. So again, the first one stays the same. When you're making the second one negative, you do have to flip that sign. Kenzie, what two x inequalities did you get?
x is greater than or equal to negative 2, and x is less than or equal to
Good. Again, there you're flipping the sign a second time because you're dividing by a negative. So if you need to think of what the graph looks like, just make yourself a little number line. You don't even have to put tick marks on it. Put a negative 2, put the positive 3. Greater than negative 2 is this way. Less than positive 3 is this way. So they meet in the middle. Therefore, Mackenzie, the solution in interval notation is
in brackets negative 2, 3.
nice. So the last thing we're going to do is just graph this in the calculator so that we can kind of see how it reflects with what we have as our answer. So going back to that calculator. How do you get absolute values? Casey.
You would go hit math, go over to number, and then just either hit 1 or enter.
Right, perfect. 1 or enter, and those absolute value symbols go in there then. So 1 minus 5x.
It's 2x.
2x. My memory is not very good. Is there a 5 in there somewhere?
Yes.
Yeah, it's the next number. Okay. Just mixing them up. And then it was less than or equal to, right? Yeah, okay. So then I'm going to change my shading to be less than, which means shade below. So whatever that inequality symbol, that always goes in front of y2. So I want y1 to be less than or have a v, here's that 5 value. The part of the v that's below 5, less than 5, is this piece on the left and the piece on the right. And if I count my x's, there is -2, and what was the other one? 3, right? You can find those again by using that intersect.